Hello students, straight back again. We've got today looking at practice problems for section 10.4 part 1. As always, you should have already done these, and now you should be checking your answers, doing any corrections, or coming back if you just couldn't figure it out and looking at it. Here we're going to be looking at percent composition problems. So here we want to find the percent composition of aluminum oxide, Al2O3, and we start by finding the molar mass of aluminum oxide. Here you'll want to be writing out everything on finding your molar mass. So we've got aluminum, we've got oxygen, aluminum. Looking at the periodic table, we find that 26.982 for its molar mass, oxygen 15.999 times 2 times 3. As there's 2 aluminums, 2 oxides. Do our multiplying and we get 53.964 grams, and we get 47.997 grams. Add that up for 101.971 grams. And we need to, for aluminum, we take its part, 53.964 grams divided by the whole, 101.971 grams. Grams divide out, leaves us 0.5292, or 52.92%. For oxygen, its part, memorize with percents, its part divided by whole, 47.997 grams divided by 101.971 grams, and we get 0.4707. Nope, not percent yet. Get rid of that percent. Which is the same as 47.07%. A quick check. Add the 2 percents together and we get 99.99%, which is acceptable. If you're off out there, it's estimated. So we're okay there. So we got 47.0% oxygen and 52.92% aluminum. That's our percent composition. And this time we got magnesium nitrate. So we've got Mg's, we've got N's, and we've got O's. Go into periodic table, we find molar mass of magnesium 24.305, nitrogen 14.007, and oxygen 15.999. As we've been doing a lot of these, you should start to remember some of these molar masses, like oxygen. We keep coming back to it over and over. It's good to remember them. From our formula, we find there's 1 magnesium, 2 nitrogens, and 6 oxygens. And we do a bunch of multiplying. 24.305, 28.014, and 95.994. These are all grams, but as percent mass, by the time we get done, units aren't going to be important because they're all going to divide out, so I'm not going to bother writing them down. And total 148.313. And to get our percent, we take, again, the parts, divide by the whole. So for magnesium, we got 24.305 divided by 148.313. Divide that and move our decimal a couple spots. Now, I'm not going to write down everything here, but we get 16.39%. If it helps you to write the 0 point, helps you prevent mistakes, make sure you write that down. Nitrogen, we've got 28.014 divided by 148.313. So divide, multiply by 100 if you want to. That'll get your decimal over twice. But 18.89%. And then oxygen, our part was 95.994 divided by 148, our whole, 0.313. Divide, move our decimal twice, or multiply by 100, and we get 64.72% oxygen, 18.89% nitrogen, and 16.39% magnesium, our little check. Add these up. This time we get exactly 100. Mine's it's close to 100 with them, a tenth or a couple hundreds, something like that. We're okay. This time we just want the percent oxygen in potassium chlorate. So we still need to go through the whole molar mass routine. So we got potassium, chlorine, oxygen. Potassium, periodic table tells us 39.098. Chlorine, 35.453. Oxygen, 15.999. 1 potassium, 1 chlorine, 3 oxygens. Multiply. First two just times 1, get what we started with, then times 3 for the oxygen, 47.997, a little bit of addition, 22.548. This time we only want oxygen, so that would be 47.997, the part that's oxygen, divided by the total, or the whole. And that turns out to be 39.17% oxygen. If you would have happened to did it out to 1 decimal place at 39.2%, that would have been okay too. There you got number 24. There you got this ammonium hexyl product here. Nice hard name to say there. I'm not even going to try to get it pronounced. Got our formula here, and we just want the percent nitrogen. So we got some nitrogens, some hydrogens, some iron, some carbon, and some more nitrogen. So nitrogen, got 2 spots here. We got 4 nitrogens here, 4 nitrogens there, and then we got 6 nitrogens over here. So we got 10 nitrogens. Yeah, so that's from periodic table, 14.007 times 10. Go ahead and list out the other molar masses. 1.0079, iron 55.847, carbon 12.011. Back there. Hydrogens, we had 4 times 4, so that would be 16 hydrogens. Iron, just one of them, and carbon, times 1, times 6. Now find nitrogen. I'm going to write it out at 140.07. We could go ahead and write these other ones out, but I'm just going to multiply, add, multiply, add, multiply, add. Just run it all through one string on the calculator to get my total, because I don't, just trying to find nitrogen, so I don't need these other numbers. And that gives me 284.11. And divide the part. 140.07 divided by the whole, 284.11, make that 8 a little nicer. And they divide, switch it to a percent, 49.30% nitrogen. So you can write down as much as you want to. You can shorten the writing down a little bit if you want to. Since you don't necessarily have to write down what you're dividing. But I show enough work so somebody looking at it knows what you are doing. It shows that you know what you're doing. And then number 25. It got a molecular formula C2H6 and has a percent composition of acetylene. Compare with that of benzene, which is C6H6. Now, if we got C2H2 and C6H6, these both have a 1-to-1 ratio of carbon to hydrogen. So that means they are going to have the same percent composition. So right now our answer, the percent composition will be the same as the ratio of carbon to hydrogen atoms is 1-to-1 for both. So if you would have went through and did the calculations, that would have been all right. Hey, you'd have seen they were the same. But we don't have to go through all that work. So and that completes our 10.4.1 practice problems. So that's all for now. Till next time, Mrs. Strike.